So this morning, I woke up, grabbed my coffee, and started scrolling through the comments like I always do. And I saw this, and immediately I was like, wait, did I miss something? I put on my detective hat, went full Sherlock Holmes mode, and started digging. And after some serious investigating, I think I finally get it. In the last video, we explored different image-to-image workflows that let you take 1 or 2 images and do all kinds of things with them. And out of all of them, the ACE++ workflow really stood out. But here's the thing. I only briefly went over it, and I have this nagging feeling that a lot of people might not fully use it. And that would honestly be a shame, because this set of tools can seriously level up your workflow. So today, we're going to take another look at ACE++, specifically focusing on local editing with LoRa, going completely from A to Z. No skipping steps, no assumptions. By the end of this, you'll totally understand how it works and how to use it. Let's get into it. Before we start, please like the video and subscribe for more tutorials like this one. Anyway, ACE++, like we talked about last time, works with 3 LoRas. The local LoRa, the portrait LoRa, and the subject LoRa. You can use them either on their own with a single image or alongside a reference image. When it comes to actually editing images with these LoRas, there are 5 different approaches. There's subject-driven generation, where the LoRa focuses on capturing the subject's core details. Then there's portrait consistency generation, which helps maintain consistency across multiple portraits of the same subject. You've also got flexible instructions or descriptions, which let you guide the AI more dynamically, and local editing. And finally, there's local reference editing, which is not the same as local editing. Local reference editing, or just reference editing, happens when you use either the portrait LoRa or the subject LoRa with 2 images. One as the base image and the other as the reference, or the driving image, which influences the final result. We're going to start from the top and work our way down. First, we'll use the same images they showcased on their project page to see if we get the same, or at least similar results. Here's how the workflow breaks down. It's actually divided into 2 parts, the ACE++ workflow itself and the Flux Inpainting and Outpainting workflow. The Inpainting and Outpainting are included because they complete the overall process. The ACE++ workflow now has 4 switches, and understanding how these work is going to make everything else a lot easier. The first switch lets you choose between base models and GGUF models. The second switch controls the 3 modes of the workflow. Mode 1 is local editing, Mode 2 is subject-driven generation and portrait consistency, and Mode 3 is reference image editing. And just to be clear, Modes 1 and 2 only use a single image. Mode 3, reference image editing, is when you bring in a second image and use either the portrait LoRa or the subject LoRa to guide the final result. The third switch is the LoRa selector, which makes it super easy to switch between the 3 LoRas. If you select 1, you're using the local LoRa, selecting 2 activates the portrait LoRa, and selecting 3 gives you the subject LoRa. You still have the Power LoRa loader below if you need to load in additional LoRas. And finally, the 4th switch lets you choose between manual masking and auto masking. The only real difference here is that instead of using Florence for auto masking, I'm using the RMBG node with grounding dyno. I actually got this idea from a comment on my last video, and honestly, it works really well. That's basically everything you need to adjust when you want to generate an image. So, now that we've got that covered, let's take a look at the first mode. Subject-driven generation. This is where you take 1 image and use it to generate a brand new one. To test it out, I'll use these 2 images and see how it performs. First, upload your image into the first upload node. This is super important. Any image you put into this first upload node is the edit image, meaning this is the image that will actually be modified. Since we're not doing reference editing, you don't need to upload anything into the reference upload node. For this test, I'll use the same prompt that the devs used on their project page. Stick this icon to the right sleeve of a stylish sports jacket hanging in a vibrant urban alley. Now, for the model switch, I'm setting it to 1. For the edit mode, I'm switching to 2 since we're doing subject-driven generation. For the LoRa switch, I'm changing it to 3. And for masking, I'm going with 1. Also, make sure the Inpainting and Outpainting group is disabled. You don't need it for this step. Alright, let's see what we get. It looks good, but I did notice something. When using the Turbo LoRa, the results aren't as consistent because you're only running a few steps. After some testing, I found that you get much better, more reliable results at 28 steps. Let's check the second image. Again, I'm using the same prompt from their project page. The fox is standing with Snow White in front of a cartoon castle gate. Let's see what we get. Like I said in the last video, this process is kind of hit or miss. You can definitely see the fox and Snow White, but this isn't exactly what we were aiming for. I'll run it again and see what we get. Still not quite what I expected. This isn't a one-shot solution. You might have to run it a few times to get the result you're looking for. And honestly, I've noticed that when I use a single image with the subject Laura, the results aren't always that cohesive. But this is where reference editing really shines. We'll come back to the subject Laura later when we do flexible instructions. So let's move on to the next test. Portrait consistency. This one also uses a single image, and for this test, I'll be using these two images. First up, I'm going with this one, and the prompt is: maintain the facial features. A girl is wearing a neat police uniform with Hops labeled on it and sporting a badge drawn in a cute Disney cartoon style like Officer Judy Hopps from Zootopia. She has large, bright purple eyes and a friendly, confident smile. She stands in front of a microphone, seemingly giving a speech or presentation, with lively gestures that convey positive emotions. The background is blurred, featuring a cartoon logo of a police department. Since we're still working with a single image, I'm leaving the edit mode at 2. For the Laura switch, I'm changing it to 2 for the portrait Laura, and I'm keeping masking as it is. Alright, let's roll the dice. This actually follows the prompt perfectly. So what was the issue with subject-driven generation? That mode is a bit more practical because it places the subject in a different environment, which is why I thought it would work a little better. Let's move on and try the second image. The prompt for this one is: transform the character in the image into Superman, wearing a blue jumpsuit, a red cape, and featuring the Superman logo on the chest. Let's see what Steph Curry looks like as Superman. And there we go. This is more like it. It took 2 tries, but the final result turned out pretty well. Next, I want to test the local Laura, which seems to be the one that confuses people the most. For this, I'll be using these 2 images. First, I'll leave the checkpoint type at 1 for GGUF, change the edit mode to 1 for local Laura, and for the Laura switch, I'll set that to 1 for local. This time, I actually want to use masking, so I'll keep the masking option set to 1. We're still only using a single image, but this time I'll manually mask out the knife and use the prompt they provided on the project site. I need penknife removed from image, according to the mask derived from mask. Let's see what we get. That didn't quite work, but there's a reason for that. And here's where things get interesting. I kind of figured out that the models were trained in Chinese, which is why the Laura sometimes behave in unexpected ways. And honestly, this discovery was a total eureka moment. Let me show you what I did. I took the original prompt, ran it through Google Translate to get the Chinese version, copied that, and added it directly into the prompt node. And look at the difference when we use the exact same seed. Just switching from English to Chinese. At first, I couldn't believe it, but the results don't lie. I'm considering adding an LLM translator into this workflow to make things a little more seamless. Next up, we've got flexible instruction or descriptions. This isn't new at all. It's basically just subject-driven generation. It uses the subject Laura to create a different image while keeping the same subject intact. Let me show you exactly how it works with an example. Again, this isn't reference editing, so we're only using one image. The checkpoint stays the same. The edit mode needs to go back to 2 for subject-driven generation. The Laura switch should be set to 3 for the subject Laura, and the masking stays at 1. The prompt I'm using is: let this car and image drive on Mars, dust kicked up. Let's see what we get. Yep. It took the car and placed it in an entirely new environment, just like we asked. You can pretty much do this with any subject. And honestly, it helps if you have a background remover just in case, especially if the results seem off. Finally, let's talk about reference image editing. This is the only time you'll need to use 2 images. The first one is your edit image, and the second one is your reference image. Let's try this out. I'm using a movie poster as the edit image, and for the reference image, I'll use a picture of Steph Curry. The prompt here is: the man is facing the camera and is serious. First, I need to change the edit mode to 3 for reference image editing. The Laura switch should be set to 2 for portrait Laura, and the masking stays at 1 because we're masking manually. Now, I'll first mask the face, cue it up, and let's see what we get. That worked exactly how it should. Now let's try 2 more images, but this time using the subject Laura. Since we're switching to the subject Laura, I'll change the Laura switch to 3. For this test, I'll be using this image as the edit image, and this skirt as the reference image that will guide the editing. I'm also changing the masking to 2 for auto masking. And one more thing, I'll add short to the segment node. The last change I'm making is enabling the background removal node. The subject Laura tends to give much better results when the background is removed first. Here's the prompt. The woman wears this skirt. So the skirt is looking a little too tightly fitted on her body. That's an easy fix. I'll add a grow mask to the workflow. That way, when you select auto mask, the mask has a little more flexibility to expand. And that's pretty much all the edit modes of the Ace Lauras. One last thing, you might have noticed how the input size determines the output image size. That's exactly why I included the Inpaint and Outpaint group. This group has 2 switches, one is for inpainting and 2 is for outpainting. You can use this to extend the images beyond their borders. Try them out and see what you end up with. So, what's the verdict? Well, it's not quite ready yet, but it's getting really close. I honestly think the next release might just blow us away. I started off using the Turbo Laura at 16 steps with the T-Cache patch, but I wasn't getting great results. Then, I swapped out the T-Cache patch for the original T-Cache, bumped the steps up to 18, and that's when things started looking good. Now, the local Laura was a bit strange. It only started working once I switched the language to Chinese simplified. And that was a huge discovery because it shows that its performance isn't really affected by how you prompt, but rather how it was trained in the first place. If it works the way I think it can, the local Laura might actually be the most useful one. It's the closest thing to Adobe's generative fill, and if we can get it running smoothly, it could make Comfy much more viable as an actual design tool. The other 2 Lauras work just fine, but the only issue I ran into was that I was using the GGUF model. When I tested it with the FP8 fill version, the results were way more consistent. I was getting better outputs with fewer runs. Let's go over how to set this up and get it running. The models we're using are FluxFill, T5 text encoder, ClipL, and VAE, plus the Ace Lauras. First, let's talk about the stuff we can grab directly from Comfy Manager. Before we go any further, if you already have Flux installed in Comfy, then you don't need to re-download anything except for the Ace Lauras. If you don't have Flux installed, follow along carefully. Open Comfy Manager and go to Model Manager. In the Type field, select Clip. In the Base field, select T5. Now, if you're using the FP version, select FP8, but if you want to use the GGUF version, scroll down and select the version that works for your system. For ClipL, leave the type on Clip and change the base to Clip. I personally use the improved ClipL, so you can download that one if you want. Finally, for VAE, change the type to VAE. Set the base to Flux1 and install the Flux VAE. That's it for the Comfy Manager setup. Next, let's move on to the manual installation for the Fill model and the Lauras. First, click the link in the description to go to Civit and download the FP8 model. Once it's downloaded, move it to the Models, Diffusion Models folder inside your ComfyUI directory. If you have a low-spec PC and want to use the GGUF version, go back to the description, click the GGUF download link, and once it's downloaded, place it in the Models UNet folder inside your ComfyUI directory. Now for the Lauras. Click the Ace++ link in the description, download the Lauras, and place them in the Models Lauras directory. I highly recommend creating separate folders inside your Models directory to keep things organized. That way, you won't have to dig through a messy folder every time you need to find something. Alright, last step, loading up the workflow. Drag and drop the workflow file into ComfyUI. Once it's loaded, check if you're missing any nodes. If you are, open Comfy Manager, click Install Missing Nodes, select the missing nodes, and install them. Once everything is installed, restart ComfyUI, and that's it. You're good to go. Thanks for sticking with me this far. If you found this helpful, hit that like button and subscribe for more content like this. And until next time, bye.